So last time what we discussed was the following. We defined what we call the random variable x. The random variable x is a number, a real number that associates with the element that we have in our sample space S. I have my sample space S. For each one element, I have a number associated with this element. This is what I call the random variable x. For this random variable x, we define what we call the probability function, the probability of capital X equal to small x, and we name it fx. Do you remember that? So for each small x, we define a function fx to be the probability of this small x that we have. Now in today's lecture we will talk about what we call the mathematical expectation. We will talk first about the mean of the random variable. We talked about the mean before, but now we will talk about the mean of this random variable x. We will talk about the variance S for this random variable x again. Then we will talk about the mean and the variance of the linear combination of random variable. Now, if I have more than one random variable and I'm combining them in a linear function, how can I find the mean and the variance of that? So let's start by defining what we call the mean or the expected value of the random variable. I have x as a random variable. I have the probability distribution function fx. The mean, or what we call the expected value, sometimes they call it the mean, sometimes they call it the expected value. It means the average, صح? But in your mind, the mean means the average, means the expected value. You cannot hear my voice. Yeah, we started. You can hear my voice or no? Okay, so the mean is what we call the expected value, or what we call the average. All of them mean the same thing. Okay, let's proceed then. So mu, the mean, the expected value of the random variable x. Be careful about the samples. احفظوا samples very well. It's equal to the sum of all x's multiply fx. Do you remember when we have the table? Do you remember when we have the table? We have x. For each x, I have fx, which is the probability of x. Do you remember the table of the random variable x, huh? We have the x value, we have the fx that associate with all the x's that we have. Multiply each x with fx and have the sum. This will give you the mean or the expected value, expected of x. This is when x is discrete. قلنا لما discrete, I'm talking about the sum. If it is continuous, we will talk about integration now. The same thing, but not a sum, it's the integration now. From minus infinity to infinity, x, fx, in case of the continuous. The same definition, the change or the difference here, that it is a sum for the discrete and it's integration for the continuous. As an example now, we have this simple example, a pair of coin tossed twice. We find the sample space. Do you remember? The first thing that we did is that we find the sample space. I have a pair coins, head and tail, again, head and tail, again, head and tail. Following the branches here, we have the outcomes head, 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 tail, tail, head, tail, tail. Do you remember that? Last time said if my random variable x is getting a head, so here I have two head, so 2. Here I have one head, so 1. One head, 1. Tail, tail, so 0. صح ولا لا? Do you remember from last time? My random variable x is the number of the heads that I have. So for 2 heads it is 2. For head, tail it is 1. Tail, head it's 1. Tail, tail it is a 0. Okay? Now the probability of the 0 is 1 time appearance, so it is 1 over 4. 4 is the overall. For the 2 heads, it appears 1 time. Now the appearance is 1 time out of 4, so it's 1 over 4. It's recorded. I'm recording the lecture now. For 1, it is the case of head tail, the case of tail head. It appears 2 times, so it is 2 over 4 اللي هو half. So we can summarize this in a table actually. I prefer to summarize the things in a table. The x, the fx is here. The x is 0 or 1 or 2. For the 0, it is 1 over 4. For the 1, it is 2 over 4 اللي هي half. For the 2, it is again 1 over 4. Their sum should equal to 1. You remember that from last time? It's like a revision for the previous lecture because we are using it again today. So the expectation, the mu of x, expectation of x is 0 في الربع, 1 في 2 over 4 اللي هي half, 2 في 1 over 4. Multiply, find the total. It happens that this time it's equal to 1. By the way, it's not 1 all the time. It happens that in this example that the mean or the average or the expectation is equal to 1. إيش معناها? This means that a person who's tossing a coin over and over again, 2 coins over and over again, will on average get 1 head per toss. هذا معناها. الaverage is 1, معناها on average he's getting 1 head each 1 toss he's doing. Okay? Now let's do one more example here. Give me a second. And this example, I'm talking about a lot that contains 7 components. I have a lot. Has 7 components. Sampled by a quality inspector here. The lot contains 4 good and 3 defective. So 4 good معناها non-defective and 3 defective components. Now a sample of 3 is taken. So out of the 7, I'm taking a 3. Is this a combination or permutation? I'm using the C or the P here. Combination, the C, صح؟ لأن الأوردر is not important. I'm choosing a component هنا, أجهزة وأشياء, صح ولا لا؟ So the order is not important. So the overall, the size of the experiment, the capital N is 7 على 3. هذا ال overall that I need to divide with all the time. So find the expected value of the number of good components in this sample. So my random variable is the good component. The x is the good component. I'm choosing 3. I'm choosing 3. So the x can be 0 good, 1 good, 2 good, or maximum 3 of them are good components. Okay? So since x represents the good component, the x can move from 0, 1, 2, and 3. Now if I take, this should be 3 here, the fx at the 0, the f at the 0 معناها إيش؟ معناها 0 of them are good. معناها the non-good, defective. Let me call this good. It's better to call this. Let me do it like good, not good, like this. So here we have 4 that are good and I have 3 defective. Okay, so if at 0 معناها 0 are good، معناها من ال 4 good I'm taking 0 and the other 3 are all from the defective divided by the overall which is 7 and 3. صح ولا لا؟ You will get that the result here is 1 over 35. Are you following up? Are you with me? Let me come to this side. Let's find now f at 1. Let me find f at the 1. F at the 1 means 1 is good. عندي 4 good. 1 of them I'm gonna take it. And I'm choosing 3. معناها يبقى عندي 2 راح اخذهم من الديفكتيف. So 3 2 divided by the overall اللي هو 7 3. Okay, you will find this equal to 12 على 35. Now the f at 2 معناها 2 of them are good, so it is a 4 2 are good. What remain is 1 لأن أنا قاعد أختار 3. So out of the defective يبقى عندي 1 divided by 7 3. You get this equal to 18 على 35. F at 3, the final thing, معناها all of them are good. So 4 3, nothing defective, so 3 0 divided by 7 3. This will give you the answer which is 4 over 35. Okay, so this summarizes all the results that we get. Now this is a general formula. We did it in the details here. I prefer if you do it in the details. No need to do it like a formula. هنا حطوا formula. Each time you change x will give you one of those relations that we have. So we have 4 relations, 1 and 2 and 3, and the 4 relations give me the values at the 0, at the 1, at the 2, and at the 3. All the values here, the expectation is x multiply with fx. يعني 0 في ال 1 over 35, 1 في ال 12 على 35, 2 في ال 18 على 35, 3 في ال 4 على 35. Multiply everything, add, get the result 1.7. So the expectation, the average here is equal to 1.7. What does it mean? معناها if I'm selecting 3 out of the 7, the average is 1.7 good component each one time we choose. The average good component, the average choice of good component is 1.7. Is it clear? Any question? So next example is an example of a continuous random variable here. As you can see in the continuous random variable, they directly give you the formula. The formula given by fx equal to 20,000 على x3, x greater than or equal to 200 and 0 otherwise. Find me the expected life of this type of device. Notice يعني أحيانا they said find the mean, أحيانا find the average. Sometimes they just say find the expected life. I know that the expected life is x fx. الميو expected life المين ولا الافريج is x في fx. معناها from minus infinity to infinity طبعا. Okay. لكن my function starts from 100, so we can shrink this to be from 100 to infinity of x fx. Okay. x fx means x multiplied for 20,000 على x3. One of the x's cancel, one of the x's here, which you remain with x squared. Okay. So the integration of 20,000, it is the integration of 20,000 على x square is minus 1 على x. Okay, it's like the integration of 20,000 x to the power minus 2. Find the integration, you will get the integration is minus 20,000 على x from 100 to infinity. At the infinity, it is 20,000 على infinity, which is a 0. It's well-known thing إن 1 على infinity is 0. You know that? Do you know that 1 over infinity is 0? ليش؟ لأن الانفينيتي تحت. So it's growing and growing and growing very big here, and the upper is fixed number. So I'm going or reaching the 0. I'm approaching the 0 here. Okay? This is why we say that 1 over infinity is equal to the 0. So the first part go to the 0 minus substituting with 100 give me 200 here, and so the answer is 200. So the average value is 200 hours. So in average the service lifetime of each one battery is 200 hours. Okay, is that clear? Any question? Why minus where? You mean in the integration here? Which minus 2? The rule said it is x to the power minus 2 plus 1 على minus 2 plus 1 with 20,000 here, don't forget it. Okay, so يطلع لي minus من هنا. Okay, now we are gonna generalize that now as for a general case. مش expectation of x بس, it's expectation of a function gx. It's expectation now, but not expectation of x. We talk about mu, which is the expectation of x. Now what if the x is gx, function in x? Mu of gx now, it is the sum of this gx multiply with fx. The expectation of x is the sum of x fx. If this x changed to be gx, the same thing, we multiply gx with fx. For the discrete case, for the continuous case, it is the integration from minus infinity to infinity gx في fx. Now, as an example, we have suppose that the number of cars x that pass through a car wash between 4 and 5 p.m. on any sunny Friday has the following probability distribution. They give me the table. Great. This table show me x, which is the number of the cars, 4, 5, 6, 7, 8, and 9, and give me the probability for each one of them. This is my function then. This is my function of x. صح ولا لا? So 4, 1 over 12, 5, 1 over 12, and so on. Their sum must equal to 1. They give me the table. They are asking me for gx equal to 2x minus 1 to find the attendance expected earning for this particular time period. So for this one, I want to find the expected time. Clearly this is discrete, so clearly I'm gonna do that for the sum. I'm gonna do that using the sum, not the integration. The expected value of gx is the expected value of the 2x minus 1 that I have here. It is the sum of gx fx. Gx is 2x minus 1 and fx is the value. The x move from 4 to 9. So I need to do it for 4, then for 5, then for 6, for 7, for 8, and for the 9, and add them all. For the 4, it is 2 fill 4, 8. minus 1 7 في ال expectation في ال probability اللي هي 1 over 12. At the 5 it is 2 multiply 5 10 minus 1 9 في ال probability اللي هي 1 over 12. At the 6 2 في 6 12 minus 1 multiply with the probability and so on with all the values, multiply, add everything, you get this result that you have. Is it clear? Any question here? Good. Now, one example for continuous random variable. The continuous random variable here given by this function that you can see, x squared over 3 for x from minus 1 to 2 and 0 otherwise. Find the expected value of gx given by 4x plus 3. يعني أبغى أجيب ميو لل 4x plus 3. I want to find the expectation of 4x plus 3. مهم الرموز عندي. Okay, the expectation of that one is the integration from minus infinity to infinity لل function 4x plus 3 multiply with fx. طبعا the integration does not need to be from minus infinity to infinity. It's fine to shrink that from minus 1 to 2 لأن it is 0 otherwise, صح? So we change it to integration from minus 1 to 2. The function is x squared over 3. over 3 طلعتها برا as a third. Multiply x squared في 4x plus 3 that you have. It's gonna be 4x3, 3x squared dx. Find the integration now. It's x4 على 4. Cancel the 4. What remains is x3. Integration of x2. It's x3 over 3. And to cancel the 3. So what remains is x3. This is from minus 1 to 2. Substitute with 2 minus the substitution at the minus 1. Get the result, it's equal to 8. You must know how to do the integration, huh? Did you review those things? Did you practice doing them? Huh? I'm asking you here. Did you practice doing the integration or no? Not complicated cases, just do simple things. Just do simple integration for the power function, for the exponential, for example. Okay? So you get the result is equal to 8 here. Now in this slide, they are discussing two things here. They are showing you two diagrams of two distributions with the same mean. As you can see, the mean show me the center of the data. Okay, the mean show me the center of the data. So the two distributions here has the same mean, which is 2. The center of the data is 2. Yet the distribution of the data is different. توزيع الداتا is different here. This one go to the right and to the left with this amount from the center, and this one go to the right and the left with this amount from the center. Now the variability or the spread measurement show me how far I go to the right and to the left from the center of the data, which is again an important factor to describe the data that I have, because as you can see here, both of them has the same center of the data, but the difference in the spread of the data make them look in a different way. Okay, this is what they are trying to tell you. And then it's important to know the center of the data, but again it's important to know some of the spread measurement to know how far I'm going to the right or to the left from the center of the data that I have. So the next thing we will talk about the most famous spread measurement, the variance اللي هو ال S. huh? In our case now, we are gonna call it as a sigma square. It's a square actually. Okay, so the variance, the S square, the variance is the sigma square here. I'm calling it a sigma square, defined to be the expectation of x minus mu square. The variance defined to be expectation of x minus mu, everything is square. The expectation means the sum of x minus mu square fx. If it is a continuous, it is the integration of x minus mu square fx. What's my mu? What's my mu here? It's the mean that we calculated previously. صح ولا لا? So now we know how to find the mean. The mean is nothing but the ex, the expectation of x. Okay? So the variance here is defined to be the expectation of x minus mu square. Another way to find it, which is the famous actually way, the easiest way to find the variance, is by finding a sigma square by the expectation of x square minus the mu square. This is the easiest way to find the variance, by finding the expectation of x square, then subtract a square of the mu that we have already. Let's see an example to understand. Now here we have the random variable x represent the number of defective parts for a machine when 3 parts are sampled from a production line and tested. The table here give me the total probability distribution values. They give me the table, great, 0, 1, and 2, and 3. They are asking me to find the sigma square. I know that sigma square is equal to the expectation of x square minus the mu square. I need the mu. The mu is nothing but the sum of x في fx. So we multiply 0 في 0.51, 1 multiplied with 0.38, 2 في 0.10, 3 في 0.10. Add everything, you got the mu. Easy, right? Now the expectation of x square معناها x square في fx, not just x, it is x square. So 0 square, 0 في 0.51, 1 square, 1 في 0.38, 2 square اللي هي 4 في 0.10, 3 square 9 في 0.01. It should be 0.1 here, I think. There is a mistake here. This one is 0.01. Do the multiplication, add everything, you get the expectation of x square. Now the variance is expectation of x square minus mu square. Expectation of x square is 0.87. mu is 0.61 ونربعها square. Then subtract and get the result. This gives you the variance. طبعا the standard deviation is what? Square root of that one. If they want the standard deviation, it's just the square root of that one. Okay? Any question here? Good. Direct. You have the rule, you apply it, صح? Nothing complicated. Now in this example, we have a continuous random variable. They are asking me to find the mean. They are asking me to find the variance. Easy. I'm talking about a continuous random variable. So finding the mean means finding the integration. Expectation of x, it is integration of x في fx. fx is 2x minus 1. If 2 is a constant, can just go outside. X will x minus 1, and the integration is from 1 to 2 because it is 0 otherwise. Do the integration now. this one is x square minus x. The integration is x3 على 3. The integration of this one is x square على 2. Substitute from 1 to 2. Find the result. You get the mean is equal to 5/3. I know that the variance is expectation of x square minus the mean square, صح? So I need to find the expectation of x square. Expectation of x square is nothing but the integration of x square في fx. Substitute with fx. 2 is a constant. Fx is x minus 1 here, this part. Multiply. This is x3 minus x square. Integrate it now. It is x4 على 4. x3 على 3. From 1 to 2. Substitute with the values. Get the result, which is 17/6. So the variance is the expectation x square 17 على 6 minus المين square اللي هو square of 5/3. Find the result. This is what you are getting. So this is the mean and the variance. Very straightforward, especially when it's a continuous. So, any question? Any question? Anything? أعيد إيش? What part exactly? Oh. المين easily. Let me do it in a clean page here. Let me show you. الحين it's clear for us إن المين لميو هي الإكسبكتيشن للإكس اللي هو إيش؟ integration x في ال fx من minus infinity to infinity. Well, variance is nothing but the expectation of x square minus the mu square. ال expectation لل x square معناها ال they give me fx is 2x minus 1. If I want to find the mean, I integrate x في ال fx. يعني x في ال fx اللي هي 2x minus 1 والintegration راح يصير من 1 إلى 2 مش من minus infinity to infinity, just from 1 to 2. خلاص بعدين it is an integration work. It 2 is a constant, it can go outside. The integration from 1 to 2 x square minus x and integrate that one. Okay? What about now? Now you can hear my voice? Oh, okay. Okay. I'm gonna repeat it. It's fine. No problem. Now you asked me about the mean, how to find the mean for this one. المين mu defined to be the expectation of x اللي هو integration because it is continuous. Follow up with me. From minus infinity to infinity x في ال fx. Okay? So in our case, it is the integration from 1 to 2 x في ال fx اللي هي 2x minus 1. 2 is a constant. We can just bring it outside. We remain with integration from 1 to 2 x في x minus 1, which is a 2 في integration from 1 to 2 للx square minus x. ونجيب الانتجريشن عادي. ونجيب الانتجريشن. The integration is 2 في x 3 على 3 minus x square over 2 from 1 to 2. Now you know how to find this one. You know how to find this one, and you can get the final result which give you the mean. Okay. واضح؟ صار واضح الحين؟ Now expectation ex square minus الميو هذه اللي احنا حسبناها square. ex square the same thing بس نحط x square. يعني انتوا عندكم مشكلة في المالتيبليكيشن هنا. ايش اللي ثبتنا الاساس وضربنا الاسس؟ احنا ضربنا x في الاكس والاكس في الماينس 1. x في الاكس x سكوير، x في الماينس 1 x. بعدين سوينا الانتجريشن. الانتجريشن we add 1 للباور، يعني اس 2 تصير اس 3 على 3 واس 1 تصير اس 2 على 2. تكامل هذا. آخر خطوة تعويض. هذا كله تكامل، والمرة الفايتة أنا شوي بعد سويت معاكم بالتفاصيل. طلبت من عندكم ترجعون للتكامل للانتجريشن بأبسط صورة، مش مرة معقد، مش مرة complicated، اللي هو الانتجريشن العادي هذا. What do you mean, Malak? It does not look like the formula above? This one you mean? يعني because we have to multiply it with the x. The previous slide. They substitute directly. They substitute. هنا you mean this one? So anything before I move? It is the same. Yeah, I told you this is this. Another way to find this one is using this formula, which is easier, which is better. Instead of using this complicated formula, we use this one. Yeah, it's the same. The variance again is the same. Okay, good. Now, same as what we did for the mu, قلنا إن احنا we have a mu for a function gx. Also, we have the variance here of a function gx. It is defined to be now gx minus the mu gx square fx, and we don't have another formula here. We are stuck with this formula in case I'm finding it for gx. So the variance of gx, it's equal to gx minus the mu gx square fx, or the integration if it is continuous, discrete, it is the sum. Let's see an example here, and you will see that we have an easier way to find it. Put this example in your mind. We will do it again with an easier way at the end of the lecture. Calculate for me the variance of gx equal to 2x plus 3. This is my gx, where x is the random variable given by the table. They gave me the table. They want me to find the variance of this one, they want me to find, they mean sigma square of 2x plus 3. Now using the rule, I will need the mu. So find the mu of 2x. It's the expectation of 2x plus 3. It is 2x plus 3 multiplied with fx. The x's are 0, 1, 2, and 3. At the 0, 2x plus 3 is 3. At the 1, it is 2 plus 3, it's a 5. At the 2, it is a 2 multiply 2, 4 plus 3, it's a 7. At the 3, it is 2 multiply 3 plus 3, it is a 9. And the fx, as you can see, it's 1 over 4, 1 over 8, 1 over 2, and 1 over 8. Multiply, add everything, get the result. This gives you the mu of the 2x plus 3. Now the rule says that the expectation of that one is the function 2x plus 3 minus the mu. The mu is 6, so it is 2x plus 3 minus 6, but square في fx. This will give me a 2x minus 3 square. My x is 0, 1, 2, and 3. At the 0, it is minus 3 square, 9. At the 1, it is 2 في 1, minus 3, which is minus 1 square, 1. At the 2, 2 في 2, 4, minus 3, 1 square, 1. At the 3, it is a 9 you will get. And the fx طبعا is the value ربع, 1 over 8, 1 over 2, and 1 over 8. Add everything, this gives you the 4. There is an easier way to find it. No need to bother the details of that one, because you will see that we have an easier way to find it. You will see that this is nothing but 2 sigma square x. You'll see that this is same as a 2 sigma square of the x. Actually, it is 2 square. 2 square في sigma square x. Sigma square x هي العادية, الفاريانس العادية, and then it is 4 here. Okay. One example here again, finding the variance of the function for x plus 3, but for a continuous random variable. So I'm talking about sigma of 4x plus 3. To find it, it is equal to the integration of the function minus the mu square multiply with the function fx. So we will need to find the mu, even though they didn't ask me to find it. The mu of 4x plus 3 is the integration of 4x plus 3 fx. So multiply it with fx. Fx is x squared over 3. 1 over 3 is outside. X squared multiply with everything that we have. So this is what we are getting. Integrate, use the boundaries here and get the result. You will get the result is equal to 8. I want you to check that you can find this result, as a practice for you. Check that you can get this integration result as equal to 8. Now the variance is the expectation of 4x plus 3 minus 8 square. So 4x plus 3 and the mu is 8, so minus 8, it will be minus 5 square, multiply with fx. The function minus mu, and mu is 8, so it will give me 4x minus 5 square here, multiplied with fx, which is x squared over 3. Multiply everything, get 1 over 3 as a common outside, get the integration. Now there is a 1 point here. Do you know how did they find the square here? Again, if you remember in the course M129, if you have a plus b square, this equal to what? The square of the first, the square of the second, plus 2 the first multiply with the second. مربع الأول مربع الثاني 2 الأول في الثاني. You cannot say it is a square b square. لا, it is a square b square plus 2ab. And if you have a minus b square, it is the square of a, the square of b, minus 2a في b. They use this here because you have 4x minus 5 square. You need to expand this one. To expand this one, you square the first, square the second, minus 2 the first with second, multiply with x squared. Again, I want you to check that you can get this one. Okay, you want me to do it in details or you can do it yourself? You want me to do that one? Okay, check. If you cannot, next time, no problem to do it with you. I have no problem to do it with you. Next time, just ask me if you couldn't do it yourself. So you get the result, it's equal to 51 over 5. Now, this theorem helped me now to find the expectation of a function. If I have expectation of a function which is ax plus b, it's a linear function here, a linear equation. The a go outside, expectation of x plus b, like before when I wanted to find the mu of 2x مثلا plus 4. I can say this is the expectation of 2x plus 4. Easily, this is the 2 of the expectation of x plus the 4. The expectation of x is the expectation that we know how to find very easy. And then multiply with 2 and add the 4. This will give you the expectation of the whole function here. Okay. If I set a as a 0, I will remain with expectation of b, it's equal to b. So expectation of a constant with no x in it, it's equal to the same. If I set b as a 0, expectation of ax is a outside, ex. Okay? The expectation of gx plus or minus hx is same as expectation of g plus or minus expectation of h, which means we can distribute the thing over the addition and the subtraction. As an application of that one, do you remember the example we did before? I told you that put it in your mind because again we will do it in an easier way. This table that we have, the gx is 2x minus 1. I'm supposed to find the expectation of 2x minus 1 here. Using the previous slide, the previous theorem here, this is 2 expectation x minus 1. الاكسبكتيشن x اللي هي الاكسبكتيشن العادية 4 في 1 over 12 5 في 1 over 12 6 في 1 over 4 7 في 1 over 4 8 في 1 over 6 9 في 1 over 6. Find everything. هذا الاكسبكتيشن, the usual expectation that we know. Find everything, the total, multiply 2 minus 1 and get the result. This will give you the same result that you got before. It's easier that way. ولا easier ولا لا? Now this expectation is nothing but the sum of x fx. Okay, and instead of doing it for a function, squaring, adding, substituting, we may get messed up with the numbers. It's easier to do it using this way. Even when you study, by the way, even when you study the previous two examples, you can just skip them and use the theorem to find the expectation of the function. Same thing here. Again, this one we did it before. We did this example before. The function given by x squared over 3 and it's from minus 1 to 2 and 0 otherwise. They want me to find the expectation of 4x plus 3. the expected value اللي هي mu. They want me to find the mu of 4x plus 3. Using that theorem هذه نفسها ال expectation of 4x plus 3. We know that this is 4 expectation x plus 3. I need to find the expectation of x. Expectation of x is simply the integration of x fx from -1 to 1 هنا for our case. Okay, from -1 to 2 here. So here they did that. They 4 outside, 3 inside. I need to find the expectation of x, the integration of x fx, which is the integration of x3 now, and 4 is outside and over 3 here. Find the integration result, substitute, and get the final result is equal to 8. Okay, is that clear? Have a look at the slide and let me know if you have any question. Yeah, the 4 already, I have the 4, صح? I have already the 4 outside, can you see? Because of the 4 that I take outside from here. And the 3 comes from the function, so it will be 4 over 3. Okay? Okay. Now, the same thing for the variance. We have a rule, make things easier. If I want to find the variance of ax plus b, this is same as a square sigma square x without the b. The b as a constant will be just cancelled. So it is a, but not just a, square sigma square x. Sigma square x اللي هي sigma الفاريانس العادية. We can just write it as sigma square. خلاص. If you have a sigma square x plus b, the coefficient here is just 1, so it is same as sigma square لأن the b will be cancelled because it's a constant. We remain with just sigma x, and this is sigma square. And the sigma square ax is a square sigma square because I don't have a b, no effect of the b here, so it is a square sigma square. For example, if you have a sigma square of 3x plus 4, this equal to 3 square sigma square. يعني 9 في السيجما square. 9 multiply with the variance that we have. Is that clear? As an application of that one, we have the following example. X is the random variable with the density function. This is a continuous random variable here. This is the function, the same one that we use. And the gx is 4x plus 3. They want me to find the variance of this random variable. I know that the variance is the variance of 4x plus 3 here that they want. This is same as 4 square sigma square, صح? The 3 will be cancelled. So this is 16 sigma square. Now the sigma square, you need to find it. The sigma square is the expectation of x square minus mu square. مش هذا الرول للسيجما square? We can find it. The mu is the integration x of x. We did it before. It's 1 over 3x3 minus 1 to 2. The integration result is 5 over 4. The expectation of x square is the integration of x square في ال fx. So it will be x4 here. 1 over 3 x4. Okay. So 1 over 3 x5, if you integrate, substitute with the boundaries, this give you the result 33 over 15. Substitute. With a 16 outside, don't forget that we have a 16 sigma square it is. So expectation of x squared minus mu squared with a 16 outside. So 33 over 15 minus 25 over 16, get the result that you have. So this is the expectation of this linear function. Is it clear? طبعا the details of the integrations are very important here. If you mess up anything, any integration detail, the result will be wrong. ماشي? So it is important for me that you can solve at least each one of the examples that we have in this slide. You must be able to do the integration by yourself, by details. As you can see here, not all the details are shown. So it's very important for me that you know how to do those things.